Hello, my name is Ivan and today we will be solving doctor prescription problem number 6. Now, this is a 3-variable system and there are many types of ways to solve these type of systems, but we will be using matrices because that's what we've been covering this for the past unit. And to start off, we want to look at our 3 equations and see if there's anything that could be done to simplify them, or if there are any zeros, meaning there's none of that variable, so that could maybe give us a shortcut. Now in this case we don't have any zeros, so that means we don't have any shortcuts, unfortunately, but we do have the last equation, which can be divided by 2. And once you do that, you get the simplified version of negative 3x minus y minus z equals 6. So now you have those 3 equations, and you want to set up your matrix. Now it doesn't matter which order you put them in because once again you don't have any zeros, so anything won't matter. You'll still have to cancel out to get that 0. So you plug it in like so, just using the coefficients. And now to solve a matrix, what we want to do is get this to be in row echelon form. And we do that by using Gaussian elimination, which is using 2 rows at a time to solve for that 0. And we call those things that we do to the rows to get them to cancel out elementary row operations. So for the first one, we want to solve that highlighted row. We want to solve for that lower left 0. And to do that, we're going to use row 3 and either or. In this case, I chose to choose the second row, and I multiply the second row by 3, and I added row 3 times 2. And here's my work up here. The 6's cancel out, and you're left with 0, 7, negative 14, negative 42. Now, the next 0, you want to write everything down the same, keep that the same, and keep the bottom new row the same, and I want to solve for that middle one. So you want to solve for the middle one, this highlighted row, and you want to get that 2 to be a 0. And the only rows you could use to do that are row 1 and row 2, because if you use row 3, you'll undo your work. So once you do, for this one, I chose to multiply the second row by 5 and add the first row times 2, like so, and that first one canceled out. I'm left with a 0, 9, negative 18, negative 54. So now I have 2 zeros in the left, and I want to get that 7 to be a 0, which is why I had it highlighted here. And to that, I simply multiplied. You can only use rows 2 and 3 because you have a 0 there, so anything that you multiply by and add it, you will get 0. That's why you're only allowed to use rows 2 and 3. So to do this, I multiplied row 2 by negative 7, and I added that to row 3 times 9. And once you do that, as you can see, everything cancels out. So you're left with a row of zeros. Now this is a true statement, and before, when we were in Algebra 2, we thought, oh, well, there's infinite many solutions, so we're done with the problem. But we're in math analysis now, which means we have to find those restrictions, because it's not just any number that's going to work. You have to follow a certain set of rules, and those rules come in the form of equations. So to do that, we want to get a row of 1s. So simplify, multiply this by negative 1/5 and this by 1/9, and you're left with this, and ugly fractions, right? But don't worry, they'll go away soon. So you write down your new equations with variables, so just add variables to your coefficients, and you're left with that. And now for z, before we got 0 equals 0, but we're going to make up a value. So we're going to say that z is a. And once we do that, we're able to plug that into the second equation. So we have y minus 2a equals negative 6. Add 2a to the other side, and you're left with y equals 2a minus 6. So now we have our values for z and y. And if we plug that into the first equation, we're able to find the third restriction. So once you plug it into the third equation, you have x plus 3/5 times y, which is 2a minus 6, minus 1/5 times z, which is a, equals negative 18/5. And you plug in your values that you found previously and distribute, and you're left with this. Now you can combine these two, and you're left with 5 over 5a, which is 1a, and then the negative 18/5 and negative 18/5, when you add them, they'll cancel out. So you simply subtract a, and you're left with x equals negative a. So these are your 3 restrictions. So now any number that you plug in here will work as long as they follow these type of equations, and we call this type of system a consistent dependent, because one line depends on the other, which means any number you plug in for one function will plug in for the other function, and it'll work for either or. Now you want to check your work by using your graphing calculator. So you go to your graphing calculator and you turn it on, second matrix, edit, and I'll delete first one here. Oops, second matrix, edit, enter, clear, oh man. Okay, well anyways, you plug in, you want to make sure that you tell the calculator that it's a 3x4, and you plug in your values. So look at that, and you simply just plug in same thing you have there, but just your first square. So -5, -3, 1, 18, 2, 3, -4, -8, -18, -3, -1, oops, make sure you check your word, -1, and 6. And second quit, you go to second matrix, math, scroll down to RREF, which is reduced row echelon form, and then second matrix, choose the one you have and press enter. And you'll see that we have a row of zeros, which means our work was correct. It is infinite many solutions, but we still have to find those values. So there you have it. We have solved Dr. Prescription problem number 6, which is an example of a consistent dependent system. Hope it helped, and thank you for watching.